A very good morning, dear students. Today I am here with you with part 3 of chapter 4, that is carbon and its compounds. Already two parts of the chapter we have done, and I hope you have seen both the videos and you like them. Now let me move further with part 3. In this part, we will discuss some important carbon compounds. Only two carbon compounds we discuss, and those are ethanol and ethanoic acid. Right, and then we'll discuss properties of ethanol and ethanoic acid. The last topic of this chapter will be soap and detergents. Okay, so let me start with the first topic, important carbon compounds, that is ethanol and ethanoic acid. Actually, carbon compounds are there are many carbon compounds, and they are really very important to us. It is difficult to study all the carbon compounds today in this chapter. Today we'll study only two carbon compounds. They are ethanol and ethanoic acid. Their molecular formula, their structure formula, and then their properties we'll consider in this session. Right? So ethanol and ethanoic acid both are compounds having carbon. They are carbon compounds. The structure formula of ethanol is here, and molecular formula of ethanol is C2H5OH, right? And there are two carbon atoms. They are joined together with a single bond. Okay, and in ethanol the functional group is OH, right? And here you can see ethanoic acid. The common name of ethanoic acid is acetic acid. The molecular formula is CH3COOH, and here you can see the structure formula for acetic acid, right? Properties of ethanol. Ethanol is a liquid at room temperature, and the melting point of ethanol is 156 K, while boiling point of ethanol is 351 K. Ethanol is commonly known as alcohol, and it is the active ingredient of all the alcoholic drinks. Ethanol is a very good solvent, and that is why it is used in medicines like tincture iodine, cough syrups, and many tonics. Ethanol is soluble in water in all the proportions. Consumption of small quantities of dilute ethanol causes drunkenness. Even though this practice is condemned, it is socially widespread practice. However, intake of even a small quantity of pure ethanol can be lethal. Also, long-term consumption of alcohol leads to many health problems. So, consumption of alcohol is not good for your health. Reactions of ethanol. Reaction of ethanol with sodium. When ethanol react with sodium, it gives hydrogen and sodium ethoxide. Okay, this is the chemical equation of reaction between sodium and ethanol. 2Na plus 2CH3CH2OH. Let me remind that it can be written like that, 2C2H5OH. So it gives 2CH3CH2O Na plus H2. And here you can see the bond formation, CH3 CHONA, right? From this alcohol, hydrogen will be removed, okay, and this sodium will be added. Now reaction of ethanol to give unsaturated hydrocarbon. Okay, unsaturated hydrocarbon means double bond between two carbon atoms. When ethanol is heated at 443 Kelvin temperature with excess concentrated sulfuric acid, it gives ethene. Okay, see here is the reaction, CH3CH2OH. When it is heated in presence of concentrated H2SO4, it gives CH2, CH2, ethene, and water. See, sulfuric acid. It is a dehydrating agent. So it removes water from ethanol, and that results that ethanol gives ethene, CH2, CH2. Right? See, from formula you can see the formula is CH3 CH2OH. Just look at the formula. Look at the formula on your screen. CH3 CH2OH. From this CH3, H is removed and this OH is removed. Okay. So what will remain? CH2 CH2 will be here. Okay. And H2O will be removed. Right. And here is the equation. Okay. Now it is more clear if you look at this equation. Okay. Breaking of bond and formation of new bond can be seen clearly over here. This is a structural formula of ethanol. C2H5OH. Okay. And see, when it is heated in presence of concentrated sulfuric acid, this CH2 will remain like that. This is CH2. Okay, and this CH2 will also remain like that. The CH2. Fine. And this H2O we will get separate. Right? So, saturated hydrocarbon is converted into unsaturated hydrocarbon. Alcohols affect living beings. How do they affect? See, when large quantities of ethanol are consumed, it tends to slow metabolic processes and to depress the central nervous system. It results lack of coordination, mental confusion, drowsiness, lowering the normal inhibitions, and finally stupor. The individual may feel relaxed but does not realize that his sense of judgment, sense of timing, and muscular coordination have been seriously impaired. Unlike ethanol, intake of methanol in very small quantities can cause death. Methanol is oxidized to methanol in the liver, and methanol reacts rapidly with the components of cells, and that causes the protoplasm to get coagulated, means clotted हो जाता है. In much the same way an egg is coagulated by cooking, इतना वो thick हो जाता है. Methanol also affects the optic nerve, causing blindness. So you can see how much dangerous it is to our health. Ethanol is an important industrial solvent. To prevent the misuse of ethanol produced for industrial use, it is made unfit for drinking by adding poisonous substances like methanol to it. Dyes are also added to color the alcohol blue so that it can be identified easily. This is called denatured alcohol. So never consume alcohol. It is very much harmful to the health. Yes, alcohol as a fuel is a very good component. Sugarcane plants are one of the most efficient converters of sunlight into chemical energy. Sugarcane juice can be used to prepare molasses, which is fermented to give alcohol. Some countries now use alcohol as an additive in petrol since it is a cleaner fuel which gives rise to only carbon dioxide and water on burning in sufficient air. Okay, see, while burning on alcohol, it gives carbon dioxide. Okay, and this carbon dioxide will be used by plants for photosynthesis. So there will be a balance in the environment. So it will be environment friendly. Okay, so alcohol as a fuel is a good use of alcohol. Now we come to the another compound of carbon, that is ethanoic acid. Ethanoic acid is commonly known as acetic acid, and this belongs to the group of acid that is called carboxylic acid. 5 to 8% solution of acetic acid in water is called vinegar, and vinegar is used as a preservative in pickles. Vinegar is an essential part of Chinese food. You must be familiar with it. The melting point of pure ethanoic acid is 290 K, and hence it is often freezes during winter in cold climates, and that is why it is called glacial acetic acid also at the time. The group of organic compounds called carboxylic acids are obviously characterized by a special acidity. However, unlike minerals acid like HCl, HNO3, which are completely ionized, carboxylic acids are weak acid. So acetic acid is a weak acid because it does not get completely ionized. While HCl is a strong acid, HCl gets completely ionized. Here are chemical properties of ethanoic acid. The first reaction is esterification reaction. When ethanoic acid reacts with ethanol, it gives ester. That is why this reaction is known as esterification, right? See, CH3COOH, that is ethanoic acid or acetic acid. CH3CH2OH, that is alcohol. So the reaction between these two compounds gives CH3, COO, CH2, CH3 plus H2O. Okay. Generally, esters are sweet smelling substances and they are used in making perfumes and flavoring agents. Here is the reaction, and after looking at this, you will be clear how the bonds are breaking and how new bonds are forming. Okay, that is ethanol, CH3, CH2OH, and that is ethanoic acid. CH3COOH. See, this is CH3COOH. Okay, and ethanol is CH3, CH2, and that is OH. Now, what do you observe? See, okay, at first let me clean it, then I'll show you again. Okay, now what do you observe? This H and that OH will be removed. Rest of the atoms will be same. And see, they will bond together in this way that we get CH3, COO, CH2, and CH3. This CH3. Okay, this CH3 and this CH3 are over here. CH3 and this CH3, they are here. So nothing is removed. Okay, now this CHO and this is also same. Right? Now this CO will be added over here. Only H from ethanol and OH from ethanoic acid is removed and we get H2O. Okay. So esterification means ethanoic acid and ethanol gives ester when they react with each other. And the reaction is known as esterification. Esters react in presence of an acid or a base and they give back the alcohol and carboxylic acid. This reaction is known as saponification because it is used in preparation of soap. Okay, okay, now see. This is ester, ethyl acetate, CH3CO, CH2, CH3. When it reacts with NaOH, what do we get? We get CH3COONA and CH3CH2OH. This reaction is known as saponification. Actually, soap are sodium or potassium salts of long chain carboxylic acid. Okay, again, this reaction is presented over here. This is ester. In presence of NaOH, we get carboxylate and alcohol. Okay. Another reactions of ethanoic acids. When ethanoic acid reacts with base, we get sodium ethonate or sodium acetate, CH3COONA plus H2O. Okay. Now another reaction of ethanoic acid with carbonates and hydrogen carbonates. When ethanoic acid reacts with carbonate or hydrogen carbonate, we get sodium acetate. 2CH3COH plus Na2CO3, we get 2CH3COONA plus H2O plus CO2. In the same manner, CH3COOH when reacts with NaHCO3, we get CH3COONA plus H2O plus CO2. So these were the reactions of ethanoic acid. Now the next topic is soaps and detergent. See, uh, mostly dirt is oily in nature, that you know. Okay, and that also you know that oil does not dissolve in water. The molecules of soap are sodium or potassium salt of long chain carboxylic acid. The ionic end of soap dissolve in water while the carbon chain dissolve in oil. The soap molecule form a structure that is called micelle. Here you can see micelle. This is micelle and that is a soap particle. You can see the head of the soap particle and there is tail. Okay, there are two parts of this soil particle and that is oil droplet. This head particle is, see this one, this head particle will not attract towards the oil while the tail parts of this particle will be attracted towards the oil, right? And when number of particles, the tail of number of particles will be attracted towards the oil and head of all the particles will go away from the oil. So a structure will be formed like micelle. Micelle means simply झाग, झाग जैसा बन जाएगा. Okay, so in the figure you can see the micelle where one end of the molecule is towards the oil droplet and the other end, that is ionic end. This ionic end faces outside. And then this form an emulsion in water. The soap micelle thus helps in dissolving the dirt in the water and we can wash our clothes clean. That is the molecule of soap. You can see there are two parts of this molecule. One is head and the another one is tail. Okay. Okay. This is the process of cleaning the dirt from the cloth and formation of micelle. At first, soap or detergent particles are dissolved into the water, that is the surface of cloth, and that is oil or grease or dirt, and these are all soap particles. Okay, and you can see there are two parts of this soap particle, that is head and this is tail. Okay, the head part जो है that is polar part, मतलब हाइड्रोफिलिक है part, और जो ये tail part है that is hydrophobic part. This is tail, right? Okay, so now what do you see? Surface stand ions orientate themselves in grease and water. Okay, this tail is attracted towards the grease. This you can see. Okay, and now aggregation begins to separate grease from the surface. What will happen? All these particles will start taking off the grease from the water. Okay, and the process will be continued in part D, you can see. Okay, all these particles will try to take this dirt off from the surface of cloth, and finally here micelle is formed and grease has uh, it is taken out from the surface of the cloth and cleaning process is completed, right? That is the cleaning process of dirt from cloth. Have you ever observed while bathing that foam is formed with difficult and an insoluble substance remains after washing with water? This insoluble substance is known as scum. This happens in hard water. In hard water, calcium and magnesium salts are present, and soap does not uh, get mixed properly with this calcium and magnesium salt, and this type of water is known as a hard water. So when we are working with hard water, we need larger amount of soap. And how can we overcome this problem? This problem is overcome by using another class of compound that is known as detergent. Detergent is also a cleansing agent like soap. Detergents are generally ammonium or sulfonic salts of long chain carboxylic acids. The charged end of these compounds do not form insoluble precipitates with the calcium and magnesium ions in hard water, and that is why they remain effective in hard water. Detergents are usually used to make shampoos and products for cleaning clothes. Here is the difference between soaps and detergent. Soaps are sodium or potassium salt of long chain fatty acid. On the other hand, detergents are sodium and potassium salts of sulfonic acids of hydrocarbons. Soaps cannot be used with hard water, or they are not effective with hard water actually. Detergents are very much effective even in hard water as well as in soft water also. Soaps are fully biodegradable, while detergents are not biodegradable. Soaps take time to dissolve in water, while detergent dissolve faster in water. Here is the structure of particle of soap, and that is the structure of particle of detergent. Here you can see the functional group, and that is different, right? So that is the difference between soap and detergent. This is saponification reaction. When vegetable oil or animal fat reacts with NaOH, we get glycerol and sodium salt of fatty acid. That is soap. Okay, this is vegetable oil. It is known as triglyceride also, reacting with base, and we get glycerol and this soap. That is the formula of soap, right? This reaction is known as saponification. Okay, here are the structure of soap particle and detergent particle. That is soap particle, this one, and that is detergent particle. Okay, and this is the tail part of soap particle. This is the tail part of detergent particle. You find it same. The difference is there in head part. Okay, and this is the head part of the soap particle and detergent particle, right? Now, what did you learn in this chapter? Let me sum up. What did we learn? Uh, what we have discussed in this chapter one by one? Carbon is a versatile element that forms the basis for all living organisms and many of the things we use. This large variety of compounds is formed by carbon because of its tetravalency and the property of catenation that it exhibits. Covalent bonds are formed by sharing of electrons between two atoms so that both can achieve a completely filled outermost shell. Carbon forms covalent bonds with itself and other elements such as hydrogen, oxygen, sulfur, nitrogen, and chlorine. Carbon also forms compounds containing double and triple bonds between carbon atoms. These carbon chains may be in form of straight chains, branch chains, or rings. The ability of carbon to form chain gives rise to a homologous series of compounds in which the same functional group is attached to carbon chains of different lengths. The functional groups such as alcohols, aldehydes, ketones, and carboxylic acid uh, show characteristics properties to carbon compounds that contain them. Carbon and its compounds are some of our major sources of fuels. Ethanol and ethanoic acids are carbon compounds of importance in our daily lives. The action of soaps and detergents is based on the presence of both hydrophobic and hydrophilic groups in the molecule, and this helps to emulsify the oily dirt and hence its removal. So, this much was there in today's session. This was the last part of the chapter. Chapter number 4 is over. Now, your today's work is to write down the question answer of the exercise in your fair book. Thank you, students. Now, we'll meet again with a new chapter.